Hi class, we need to take a look at parametric equations since we're going to be doing integrals and derivatives of these later in the semester. And here's the idea. You're technically going to have two functions based on t, which is technically your parameter, and it typically represents time. And all it is the following. So, both of your functions are expressed in terms of t, and t for most of the problems that you're going to see, like the applications, it's going to represent time. So what it represents is, well, you have x and y coordinates, but based on the parameter t, and you're able to determine where a particle or a position on the x and y axis is based on another variable. Now, here's the main idea. As you're graphing parametric equations, you have to take a look at what is the domain of the parameter in this situation it happens to be any real value. And I'm just going to ask you for a total of 3 coordinate points. So you would typically create a table. This is your t. Then you technically have x is equal to t squared. Y is equal to t plus 1. And then technically your x's and y's. So on any question that you're actually graphing, I just want 3 coordinate points and then provide a basic sketch. You want to start at 0 and then evaluate technically positive or negatives as long as you do a total of 3 coordinate points. So let me start at 0. So your x value is 0 square or 0. Your y value, it's technically 0 plus 1 or 1. Our coordinate point, it's going to be 0, 1. So let me create a sketch of the actual function. And then we're going to have the coordinate point 0, 1, which is here. And it represents t is equal to 0. So the coordinate point at t is equal to 0, it's going to be at 0, 1. And then you can select a positive and a negative or go in any direction. Let me just select a positive. So I'm going to be selecting 1. And then x is equal to 1 squared, which is 1. Your y value, it's going to be 1 plus 1, which is 2. Or our coordinate point, 1, 2. So we're looking at 1, 2. Let me put it in red. So this is technically 1, 1, 2. It's technically here. And then let me select a negative value. In this situation, negatives are actually okay to use. We may have some problems that you can only use positive values since it may most likely represents time. So for this one, we're looking at negative 1. So your x is equal to negative 1 squared, which is 1. Your y is equal to negative 1 plus 1, which is 0. So coordinate point, we're using a 1, 0, which is going to be here. Now, we can select more coordinate points, but you can actually see the graph of this one. It's going to be this sort of a parabola, but these functions actually follow the actual path. So in this case, this particular one, it's going in this direction. So the coordinate point 1, 2 is at t is equal to 1. The coordinate point 1, 0, it's at t is equal to negative 1. So this is t is equal to negative 1. So our actual graph, it's going in this direction. These are your coordinate points. Now, let's take a look at problem B. And this is supposed to be B. They're actually saying for us to eliminate the parameter and express it as a rectangular equation. Okay, so this is actually very simple. You basically select one of the actual equations and express it in terms of just y. So in this case, you technically have that x is equal to t squared. So if you were gonna actually just express everything in terms of x's and y's, you would have that t is equal to plus or minus the square root of x which happens to be the resulting solution of taking the square root of those two. And then in this case, you would have that t is equal to plus or minus the square root of x. So your y value, which is t plus 1, happens to be y is equal to plus and minus the square root of x plus 1. So you would have that y is equal to the square root of x plus 1 and y is equal to negative square root of x plus 1. They don't mention anything about the rectangular coordinate equation being an actual function, so that's why I'm expressing it as a plus and minus. They also don't want the actual sketch, but let me just put the sketch on this one. As you can see, it's going to start at 0, 1, and then technically going in that direction, and then it's going to go in this direction. Now, for the rectangular coordinate, you don't need the arrows because what they're trying to do is basically eliminate the parameter. You only need the arrows on the previous one. So this is y is equal to the square root of x plus 1. And then this is y is equal to negative square root of x plus 1. That would be it for this particular example.